Hello students, welcome to this lecture 1 Statistics. So in this lecture we will discuss mode of group data. Okay. So in our previous lecture we have discussed mean of group data. So in this lecture we will discuss mode of group data. So recall from class 9, a mode is that value among the observations which occurs most often. Okay, and that is the value of the observation having the maximum frequency. So you have studied in your class 9 what is mode. Okay, so a mode is that value among the observations which occurs most often, and that is the value of the observation having the maximum frequency. So further we discuss finding the mode of ungrouped data. Okay, so we have discussed finding the mode of the ungrouped data, and here we shall discuss in this lecture ways of obtaining a mode of group data. Okay, and it is possible that more than one value may have the same maximum frequency. Okay, so it is possible. So more than one value of may have the same maximum frequency. So in such situations, the data is said to be multi-modal. Okay, so when you get more than one mod, then that case you will get multi-modal observation data. Okay, so the data is said to be multi-modal. So though group data can also be multi-modal, we shall restrict ourselves to problems having a single mod, one mod. Okay, so now let us first recall how we found the mod for ungrouped data through the following example. Okay, so here by this example, here we will recall how to find the mod for ungrouped data. Okay, so let us see this example. So in this example here we have the wickets taken by a bowler in 10 cricket matches are as follows. Okay, so we have given this data. Actually, we have given the wickets taken by a bowler in 10 cricket matches. Okay, so we have this data. So 2, 6, 4, 5, 0, 2, 1, 3, 2, 3. And here we have to find the mod of the data. Okay, so how can we find the mod of the data? So let us see how to find it. So first of all, you have to let us form the frequency distribution table of the given data as follows. Number of wickets 0, 1, 2, 3, 4, 5, 6, and number of matches 1, 1, 3, 2, 1, 1, 1. Okay, when number of wickets in number of matches 1, then number of wickets 0, number of matches 1, that case also number of wickets is 1. Okay, and number of matches when 3, then the number of wickets is 3, is 2. Okay, and when number of matches is 2, then number of wickets is 3. When number of matches is 1, then the number of wickets is 4, and number of match 1, then number of wickets 5, and number of match when 1, then number of wickets is 6. Okay, so clearly 2 is the number of wickets taken by the bowler in the maximum number, that is 3. Okay, so here 3 two workers, 2 appears 3 times, and this is the maximum frequency. Okay, so 2 is the number of wickets taken by the bowler in the maximum number of matches. So the mod of this data is 2. Okay, so mod of this data is 2. So we have here given ungrouped data, and we have found the mod of the data is 2. And now let us in a group frequency distribution, it is not possible to determine the mod by looking at the frequencies. Okay, so for group data, for group frequency distribution, here we need a formula. So here we can only locate a class with the maximum frequency called the model class, and the mod is a value inside the model class, and is given by the formula mod this is equal to lower limit of the class L plus f1 minus f0 divided by 2f1 minus f0 minus f2 into h. Okay, so let us now discuss what is L, what is f1, what is f0, what is f2, and what is h. So where L lower limit of the model class. So L is the lower limit of the model class, and here h is the size of the class interval. So assuming one class sizes to be equal, okay, we assuming this one class sizes to be equal. And f1 is basically frequency of the model class, and f0 this is frequency of the class preceding the model class. Okay, so f0 is the frequency of the class preceding the model class, and f2 frequency of the class succeeding the model class. Okay, and now let us consider the following examples to illustrate the use of this formula. Okay, so now we explore some examples where we use this formula. So let us discuss here this example here. In this example here we have a survey conducted 120 households in a locality by a group of students, resulted in the following frequency table for the number of family members in a household. So family size, when 1 to 3, the number of families, there are 7. When family size 3 to 5, then number of families, there are 8. And when family size 5 to 7, then there are number of families 2. And when family size 7 to 9, there's number of families 2. And when family size 9 to 11, then the number of families is 1. Okay, so we have given this data, and basically we have to find the mod of this data. Okay, so find the mod of this data. So let us solve this example. So here the maximum class frequency is 8. Okay, so you can visualize here. So now maximum frequency is here 8. Okay, and the class corresponding to this frequency is 3 to 5. Okay, so corresponding class is 3 to 5 here, and so the model class is here 3 to 5. Okay, so 3 to 5 is the model class in this data. So now model class 3 to 5, lower limit of this model class is 3, that is L is equal to 3. Class size H is equal to 5 minus 3, that is equal to 2. And frequency F1 of the model class is 8. And frequency F0 of the class preceding the model class is 7. Okay, so preceding the model class of the frequency is actually 7. Okay, and F2, frequency F2 of the class succeeding the model class is 2. Okay, so now let us substitute these values in the formula. Then we get we know this formula mod this is equal to lower limit L plus f1 minus f0 divided by 2f1 minus f0 minus f2 times h. Okay, so this is equal to 3 plus 8 minus 7 divided by 2 into 8 minus 7 minus 2 into 2. Okay, and if we now calculate it, then you will get this is equal to 3 plus 2 by 7, and this is actually equal to 3.286. Okay, so therefore the mod of the given data above is 3.286. Okay, so now let us discuss next example. So in next example here we have the marks distribution of 30 students in a mathematics examination are given in table 13.3 of example 1. Okay, so there in example 1 there we have discussed the marks distribution table of 30 students in a mathematics examination. Okay, so find the mod of this data. also compare and interpret the mod and the mean. Okay, so let us solve this problem. So here refer to the table 13.3 of example 1. So you can see example 1 there. You will get table 13.3, and here since the maximum number of students, that is 7, have got marks in the interval 40 to 55. Okay, so the model class is 40 to 55. Therefore, the lower limit L of the model class is equal to 40. The class size H is equal to 15, and the frequency F1 of model class is 7, and the frequency F0 of the class preceding the model class, this is equal to 3. Okay, so and now the frequency F2 of the class succeeding the model class, this is equal to 6. And now if we substitute these values in the formula, so we know this formula, mod this is equal to lower limit L plus F1 minus F0 divided by 2F1 minus F0 minus F2 times H. Okay, so now substitute these values in this formula, then we get mod this is equal to 40 plus 7 minus 3 divided by 14 minus 6 minus 3 times 15, and this is equal to 52. Okay, so mod is equal to 52. So the mod marks is 52. Okay, and now from example 1 you know that the mean marks is 62. Okay, so the maximum number of students obtain 52 marks, while on an average a student obtain 62 marks. Okay, so the maximum number of students obtain 52 marks, and while on an average a student obtains 62 marks. Now give some remarks. Okay, so in first here in example 6 the mod is less than the mean, but for some other problems it may be equal or more than the mean also. Okay, so this is not always true, mod is less than mean. Sometimes for some other problems it may be equal or more than the mean also. Okay, and second remark, it depends upon the demand of the situation whether we are interested in finding the average marks obtained by the students or the average of the marks obtained by most of the students. Okay, so in the first situation the mean is required, and in second situation when we need the average of the marks obtained by most of the students, that case the mod is required. Okay, and here we perform activity 3. So continuing with the same groups as from in activity 2 and the situation assigned to the groups. So ask each group to find the mod of the data. They should also compare this with the mean and interpret the meaning of both. Okay, so here we have our remark. The mod can also be calculated for group data with unequal class sizes. However, we shall not be discussing it. Okay, so now here we discuss median of group data. Okay, so as you have studied in class 9, the median is a measure of central tendency which gives the value of the median most observation in the data. Okay, so recall that the finding the median of ungrouped data that we have discussed in our class 9. So we first arrange the data values of the observation in ascending order. Okay, so first step to do, you first arrange the data values of the observations in ascending order. Then if n is what, the median is basically n plus 1 by 2th observation. Okay, and if n is even, then the median will be the average of n by 2th and the n by 2 plus 1th observations. Okay, so when n is what, the median is n plus 1 by 2th observation, and when if n is even, then the median will be the average of the n by 2 and n by 2 plus 1 observations. So suppose we have to find the median of the following data, okay, which gives the marks out of 50 obtained by hundreds in a test. Okay, so we have given marks obtained in 20, 29, 28, 33, 42, 38, 43, 25, and number of students are given to us 6, 28, 24, 15, 2, 4, 1 and 20. So first we arrange the marks in ascending order and prepare a frequency table. Okay, so this is as follows. So first of all, we arrange in ascending order marks obtained. Okay, so 20, 25, 28, 29, 33, 38, 42, 43, and their number of students, that is actually frequency, 6, 20, 24, 28, 15, 4, 2, 1. Okay, so if we add them, then you will get total 100. Okay, so sum of frequency is 100. So here n is basically 100. So here n is equal to 100. So total number of students, n is equal to 100, and which is actually even. Okay, so n is 100 and this is even. The median will be the average of the n by 12 and n by 2 plus 1 observations. That means that is 50 and 51, 51st observations. So 50 and 51 observations. To find this observation, we proceed as follows. So marks obtained when 20, the number of students 6. After 25, number of students 6 plus 20, that is equal to 26. After 28, number of students 26 plus 24, that is equal to 50. Okay, and when after 29, the number of students 50 plus 28, that is 78. After 33, the number of students 78 plus 15, that is equal to 93. Okay, and up to 38, number of students 93 plus 4, that is equal to 97. Okay, and up to 42, number of students 97 plus 2, that is equal to 99, and up to 43, number of students 99 plus 1, that is equal to 100. Okay, so now we add another column depicting this information to the frequency table above and name it as cumulative frequency column. Okay, so here we basically add another column depicting this information to the frequency table above and name it as cumulative frequency. Okay, so we add this column. Basically we added this column. Okay, so marks obtained when 20, number of students 6 and cumulative frequency 6. When marks obtained 25, number of students 20 and cumulative frequency is 26. When 28, 24, 50. When 29, then number of students 28 and cumulative frequency to 78. When 33, then 15, then 93, 38, then 4, then 97, 42, then 2, then 99, 43, then 1, then 100. Okay, so from this table above we see that 50th observation is 28. Okay, 50th observation is 28. So how will get it? So actually by observation, 50th observation is 28 and 51st observation is 29. So now median, this is equal to 28 plus 29 by 2, that is equal to 28.5. Okay, so median is equal to 28.5. The part of the table 13.11 consisting column 1 and column 3 is known as cumulative frequency table. Okay, so this table is known as cumulative frequency table. And the median marks 28.5 conveys the information that about 50% students obtain marks less than 28.5. Okay, and another 50 students obtain marks scored more than 28.5. Okay, so this conveys the information that about 50% students obtain marks less than 28.5 and another 50 students obtain marks more than 28.5. Okay, so now let us see how to obtain the median of group data through the following situation. Okay, so now we will see how to obtain the median of the group data. So consider a group frequency distribution of marks obtained out of 100 by 53 students in a certain examination as follows. So here we have table 13.12. So here we have marks 0 to 10 when number of students 5, 10 to 20 number of students 3, 10, 20 to 30 number of students 4, 30 to 40 number of students 3, and 40 to 50 number of students is 3, and when 50 to 60 number of students is 4, when 60 to 70 number of students 7, when 70 to 80 number of students 9, when when marks is 60 to 70 number of students 7, when marks 70 to 80 number of students 9, and so on. Okay, so from the table above, try to answer the following questions. So how many students have scored marks less than 10? And the answer is clearly 5. Okay, so the answer is clearly 5. And how many students have scored less than 20 marks? So observe that the number of students who have scored less than 20 include the number of students who have scored marks from 0 to 10 as well as the number of students who have scored marks from 10 to 20. So the total number of students with marks less than 20 is basically 5 plus 3, that is 8. So we say that the cumulative frequency of the class 10 to 20 is 8. Okay, so similarly we can compute the cumulative frequencies of the other classes, that is the number of students with marks less than 20, 30, less than 40, less than 100, and we give them in table 13.13 given below. Okay, so marks obtained less than 10, number of students 5, less than 20, number of students 8, less than 30, number of students 12, and when less than 40, the number of students 15, and when less than 50, number of students 18, when less than 60, the number of students 22, less than 70, number of students 29, now less than 80, number of students 38, less than 90, the number of students 45, okay, and less than 100, number of students 53. So the distribution given above is called the cumulative frequency distribution of the less than type. Okay, so here 10, 20, 30, 40, 50 up to 100 are the upper limits of the respective class intervals. Okay, so these are upper limit of the respective class intervals. So we can similarly make the table for the number of students with scores more than or equal to 0, more than or equal to 10, more than or equal to 20, and so on. So from table 13.12, we observe that 153 students have scored marks more than or equal to 0. Since there are 5 students scoring marks in the interval 0 to 10, and this means there are 53 minus 5, that is equal to 48 students getting more than or equal to 10 marks. And continuing in the same manner, we get the number of students scoring 20 or above as 48 minus 3, that is equal to 45. Okay, and 30 or above as 45 minus 4, that is 41, and so on. That is shown in table number 13.14. Okay, so more than or equal to 0, now marks obtained more than or equal to 0, the number of students 53, and the marks obtained more than or equal to 10, there are number of students 48. Okay, and so one here you can see by in this table. Okay, so the table above is called a cumulative frequency distribution of the more than type. Okay, so this is the cumulative frequency distribution of more than type. So here 0, 10, 20 up to 90 give the lower limits of the respective class intervals. Okay, so now to find the median of the group data, so we can make of any of the cumulative frequency distribution. So let us combine tables number 13.12 and tables number 13.13 to get the table number 13.15 that is given below. Okay, so marks when obtained 0 to 10, number of students 5, cumulative frequency 5. Okay, and when marks obtained 10 to 20, number of students there 3 and cumulative frequency is 8. And so on. Here you can see. So from this table, now in a group data, we may not be able to find the medial observation by looking at the cumulative frequencies, as the medial observation will be some value in a class interval. Okay, so it is therefore necessary to find the value inside a class that divides the whole distribution into two halves. Okay, but which class would be should this be? So to find this class, we find the cumulative frequencies of all classes and n by 2. Okay, we now locate the class whose cumulative frequency is greater than n by 2 or nearest to n by 2. This is called the median class. Okay, so in the distribution above, where n is 53, so n by 2, that is 53 by 2, this is equal to 26.5. So now 60 to 70 in this class is the class whose cumulative frequency 29 is greater than and nearest to n by 2, that is 26.5. Okay, so therefore 60 to 70 is the median class. After finding the median class, we use the following formula for calculating the median. Okay, so median is equal to L plus n by 2 minus cumulative frequency by F into H. Okay, so where L is the lower limit of the median class, n number of observations, CF cumulative frequency of class preceding the median class, and F frequency of the median class, H class size. So here we assuming class size to be equal. Okay, so L is lower limit of the median class, n is number of observations, CF is cumulative frequency of the class preceding the median class, F is frequency of the median class, H is the class size. So substituting these the values, n by 2, this is equal to 26.5, L is equal to 60, CF is equal to 20, F, that is frequency of the median class, is 7, and H class size equal to 10. In the formula above, if we substituting these values in the formula, then we get median. This is equal to 60 plus 26.5 minus 22 divided by 7 into 10, and this is equal to 60 plus 45 by 7, that is equal to 66.4. Okay, so about half the students have scored marks less than 66.4 and the other half have scored marks more than 66.4. Okay, so now let us discuss example. So a survey regarding the heights in centimeter of 51 girls of class 10 of a school was conducted, and following data was obtained. Okay, so when height less than 140, there are number of girls 4. When height less than 145, there are number of girls 11. When number of height is less than 150, then there are number of girls is 29. When less than 155, then there are number of girls 40. When less than 160, there are number of girls 46. Okay, and when less than 165, there are number of girls 51. So here find the median of the height. Okay, so to calculate the median height, we need to find the class intervals and their corresponding frequency. So the given distribution being of less than type, 140, 145, 150, 165, give the upper limit of the corresponding class intervals. So the classes should be below 140, 140 to 145, 145 to 150, up ... 160 to 165. So observe that from the given distribution, we find there are 4 girls with height less than 40. That is the frequency of the class interval below 140 is 4. Now there are 11 girls with heights less than 145 and 4 girls with height less than 140. So therefore the number of girls with the height in the interval 140 to 145 is 11 minus 4, that is equal to 7. Okay, similarly the frequency of 145 to 150 is 29 minus 11, that is equal to 18. For 150 to 155 it is 40 minus 29, that is equal to 11, and so on. So our frequency distribution table with the given cumulative frequencies becomes this table number 13.16. So at the class interval below 140, frequency is 4, cumulative frequency is 4. Okay, when class interval 140 to 145, frequency is 7, cumulative frequency is 11. And when class interval 145 to 150, frequency is 18 and cumulative frequency is 29. For class 150 to 155, frequency is 11 and cumulative frequency is 40. And for class interval 150 to 160, frequency is 6 and cumulative frequency is 46. And for class interval 160 to 165, frequency is 5 and the cumulative frequency is 51. Okay, so now here n is basically 51, so n by 2, that is 51 by 2, that is equal to 25 by 25.5. okay, so this observation lies in the class interval 145 to 150. So here the median class is basically 145 to 150. So then L, the lower limit, is equal to 145, and CF, that is cumulative frequency of the class preceding 145 to 150, is 11, and the frequency of the median class 145 to 150 is 18. Okay, F is 18, and H, the class size, is equal to 5. So using the formula, median is equal to L plus n by 2 minus CF by F times H. Then we if we substituting these values of L, F, N and CF and H, then we have median is equal to 145 plus 25.5 minus 11 by 18 times 5, and if we calculate it, then you will get this is equal to 145 plus 72.5 divided by 18, and this is equal to 149.03. okay, so the median of the given data is 149.03. So I stop here this lecture. Thank you very much to all of you.